We've done 3 days of this unit. What type of triangle have we always been working with? Three right triangles. All right. Still going to be talking about right triangles today, except they're going to be special. That's all I can really say. Special right triangles. I need you to help me out at first, though. This is on you guys. I'm not providing answers here. This is on you guys. Take a look at triangle ABC. It's a right triangle. Notice I marked BC and AB congruent. Can you guys find the other two angles for me then? I know that that's a right angle. How about the other two angles? Remember, those sides are congruent. What do we know about the angles across from them then? What do I know about the angles across from those two congruent sides? 7? They're congruent. Find them. Okay, you know there's 180 degrees in a triangle. If those two sides are congruent, what are the other two angles then? And what do they end up being? Both those angles. It's 2.
I didn't get it.
Come on, Nate. Let's go. Let's go. 11? 45, 45, right? So 45 degrees, 45 degrees. All right, what's AB then? Not asking anything crazy here. What's the length of AB? Just stick with me. 7, what's the length of AB?
2.
Also 2, because they're congruent, right? They're 2. And how can I find AC now? Come on, we've done 3 days of this unit now. How can I find the length of AC in that triangle? Let's not forget everything. 6, how can I find AC? Let's Pythag, yep. 2 squared plus 2 squared equals C squared. Major check rated in midterm. Stuff on asking. Okay. If you want to see it, come on in. 4 equals C squared. 8 equals C squared. And since we are in an above average math class, they tell me. Yep, go ahead, break it down for me. What's 8 broken down? Square root of 8 broken down. What do you have here for me? 5?
Got 2.8.
Holy shit. What have we? How long have you been in this? Do you think I want that decimal?
No.
I want you to break down, simplify square root of 8.
2.8. Wait, what do you mean simplify? Like
Find the biggest perfect square, right?
that-
gee, yeah,
that
the thing we've been doing all year long.
Okay. Yeah.
Every time I always say I don't want
Yeah.
that sloppy decimal on your calculator. What did you give me? The sloppy decimal on your calculator.
So
How are
We're
you
just-
decent in this class? I like because when I call on you, it's like
wouldn't it stay the same? Because it's
what's a perfect square that goes into 8?
4.
Okay.
Yeah. So 2 and 4.
All right. So what's my side here?
So then it's 2 and the radical 2. Yeah.
Somebody. You good?
Yeah.
You good? Okay. You don't see it yet, but you will see a pattern after we do the next one. Notice I already put the 45s in there, so what's got to be angle ABC then? If both those angles are 45, angle ABC is going to be 11. 90 is 90 degrees. Good. So that's 90. How about BC then? How about BC? What's the length of BC? 9? 5. Good. Because what's across from the 45s are congruent. And now how can you find AC? BC is 9, or 5, sorry, 9. BC is 5. How can you find what AC is? 2.
Using Pythagoras.
Here we go again, right? 5 squared plus 5 squared equals C squared. $25 and 25 equals C squared. C squared equals 50. Break that down. Break down square root of 50 for me. $12.
5 radical 2.
Oh, you didn't want to give me the decimal? All right, let's talk about what we see right now, because this is your first special triangle today. What do you notice about the angles? What do you know about the angles inside both of those triangles? Spence.
Yeah, right angles and there's 245.
245s. Welcome to what we're going to call the 45, 45, 90 triangle. All right, so conclusion. In a 45, 45, 90 triangle, okay, in a 45, 45, 90. So the angles have to be 45, 45, 90. What do we notice? First thing I'll ask, what do you notice about the legs of a 45, 45, 90? The legs are always 9 congruent. So there's fact number 1. Legs are congruent. And I'll be honest with you guys, I don't want to keep doing pi fac. I want to get to the hypotenuse like that. So if I know the leg is 10, I can get to the hypotenuse like that instead of doing pi fac. Anybody see the relationship? Leg was 5. Hypotenuse was 5 radical 2. Leg was 2. Hypotenuse was 2 radical 2. I want to get to it like that now. No more pi fac. We don't have time. So I can say, and you guys are going to finish this for me. Hypotenuse in a 45, 45, 90 is equal to, what do I need to do? Just explain to me in your own words if you're confident. What do I need to do to find the hypotenuse without using pi fac? Anybody see the pattern or a quick way to get to the hypotenuse? And go ahead, just in your own words.
The value of the legs with radical 2.
Okay, it's going to be whatever the leg is, leg times radical 2 always. So that's how you find the hypotenuse in a 45, 45, 90. It's going to be the leg, whatever the leg is, times radical 2. And that's all I'm giving you today. We're just going to work in a 45, 45, 90. But here's the thing. Since we're dealing with the radical, some of these are going to get a little bit tougher with the algebra. But that's at a 45, 45, 90 triangle. The legs are always equal. You want to find the hypotenuse. It's equal to whatever the leg is times radical 2. Questions, comments before we get going? All right, let's do this. Find the missing sides. Okay, I got a 45, 45, 90. Let's find the missing sides. It goes from very easy to pretty difficult at the end here. So find the missing sides. If you need to use pi fac, go ahead. I'm going to try to push you away from pi fac, though. So here we go. First thing, what is BC going to be here? BC. 2? 6. Done. BC 6. Legs are congruent in a 45, 45, 90. Now let's go to AC. No pi fac. If you don't want to, you can use it on the homework, but let's try not to use it. Let's use the rules instead. Hypotenuse equals leg times radical 2. Boom. What's AC going to be? 1?
6 radical 2.
6 radical 2. Done. Leg times radical 2. We all good before we get a little bit, the algebra gets a little more intimidating. I wish it was this easy. All right, let's go to number 2. Everyone identifies it's a 45, 45, 90. What side do you know right away? BC is radical 5. What side do we know right away? 5?
AB is also radical.
AB, good job. Also radical 5. Okay, now here's where it gets a little nuts with the algebra. So let's slow it down. The hypotenuse, AC. How do I find that? Go back to your rule on the previous page if you need to. It's how do you find the hypotenuse? Just give me the rule. I just want to hear the rule from you. Hypotenuse equals 10. Yep, and I don't expect you guys to write this down. I'm just slowing it down for you. Leg times radical 2. Let's keep going. How long is the leg? So I can plug it in. 4. How long's the leg up here? Ready, everyone? Radical 5 times radical 2. Got to reteach all this again. Remember yesterday? I couldn't add these, right? Because what's underneath is different. But multiplying, you can multiply whatever you want. It doesn't matter the numbers underneath. Adding, the numbers have to be the same underneath. Multiplying does not. So I can just multiply those two and get a hypotenuse of radical 10. I don't want a decimal. You know that. I don't want radical 5 times radical 2 and wherever that decimal is. So you can multiply whatever you want. You just can't add them. Questions? All right, let's get a little bit more complicated. BC is 3 radical 2. What other side do you automatically know? Let's get it out of the way. 5. Okay, AB is equal to 3 radical 2. Everyone ready for AC? I just want to know how to find it. How do you find AC? Give me the rule, put it in numbers, I don't care. AC. 12.
3 radical 2.
Ready? Hold on. Leg times
Radical 2.
radical 2. Everyone see that? Leg times radical 2 will get me to the hypotenuse. Ooh, how do I do this now? Keep going. Ready? It's going to be 3 times the 1 that's out in front. And then radical 2 times radical 2 will give you radical 4. Anybody notice anything? Because I'm going to ask you to keep going. What do you see up here? I got 3 radical 4. Something should light up. Square root of 4. So this is going to be 3 times 2. 6. Leg hypotenuse equals leg times radical 2 in a 45, 45, 90. Ooh, whoa, how about this one? What's a little different about this one now? Yeah, I have the hypotenuse and I'm looking for the legs. Ooh. All right, ready? No issues. What is AC? That's the what of the diagram. AC is your 10. AC is the what? Which is the leg or hypotenuse? Hypotenuse. So I'm going to get the hypotenuse rule. Hypotenuse equals leg times radical 2. I'm going to just write the rule out. Now, 8 radical 2 is the hypotenuse. Plug it in for the hypotenuse in the rule. 8 radical 2 equals, you can put x for the leg. That's what we're trying to find. Radical 2. Or if you want to put the multiplication symbol in between. Okay, how do I get x? How do I get the leg x by itself? Just use your rules, guys. That's it. How do I get x by itself here? What do I need to do with the radical 2? What's it look like? 11? Are they being added? What's happening between these two, Kelsey? Okay, so go ahead. How do I divide by? There you go, radical 2. And oh, look what happens on this side, kids. What's going to happen?
8 equals x.
What happens to those radical 2's? Good, disappear, yep. So I'm ending up with the leg equals 8. So BC equals 8. And then what do you know about AB then? 9. What do I know about AB? It's also 8. Legs are equal. Going to get a little tougher. How's everyone feel about this one? We okay? We sure? Just use the rule. That's all I'm asking. Use the rule. Hypotenuse equals leg radical 2. That's all I'm asking for. Ooh, now we get serious. right, find the legs. We know they're equal. What's 6 up here? What's 6? That's the what? 6? Huh. That's the hypotenuse. Hypotenuse equals leg times what? 2.
Leg times radical 2.
There you go. Just like I did in the previous problem. How do I get rid of the radical 2 to get x by itself? 2 again?
5 divide by radical 2.
Yep. All right, now let's talk here. Let's slow it down. I don't want a decimal answer. Do you think you can divide these and give me 3, a radical 3? No, I can't do that. Definitely one's inside a radical, one's not. And please tell me, seriously, last year, did you go over how it's not okay to have a radical in your denominator in the bottom? No. No?
Yeah.
Maybe. Some of you did, some of you didn't. Good talk as always. Why do we even bother asking? All right, so let me write this out. X equals 6 over radical 2. Good answer, correct answer, but you cannot leave a radical in the bottom of a fraction. Okay, you cannot leave a radical in the bottom of the fraction. So we need to get it out of there. Anybody who did this last year remember how to get it out of the bottom? Okay, that's fine. So first, we're all good. You can't leave an answer with a radical in the bottom. Okay, how do I get rid of it or remove it from the bottom? You multiply the top and the bottom by that radical. So I'm going to multiply the bottom by radical 2 and the top by radical 2. Watch how it gets removed now. So no radical in the denominator. So to remove it, I multiply the top and the bottom by that radical. All right, let's talk. Anybody know what happens when you multiply a radical by itself? If not, check on your calculator. What happens when you multiply? Go ahead, check. You'll remember it. This will be the last time you have to do it on your calculator. When you multiply a radical by itself, everyone sees what happens? It just needs, you just get the number underneath it. Everyone getting 2 out? So in the denominator, I get 2. No more radical. On top, I can't, there's not much I can do. You can multiply them, but you're going to get a decimal. So we just leave it as 6 square root of 2. Is there a radical in the denominator anymore? Perfect. But anybody else have a problem with my final answer? Because I do. I got one slight. Spence, what's your deal? Yeah, you got to keep simplifying. You can do 6 over 2, which ends up being what? 3 radical 2. Yep. So there's my BC and AB. BC, 3 radical 2. AB, 3 radical 2. So you'll get those today. All right, one more, and then you're on your own in your groups. Diagonal length of 10. You guys remember what a diagonal was? Diagonal length of 10, the square. There's a couple ways to go about this. All right, so I see a lot of you guys drawing in both diagonals. This is a square, so what do you know about both of these diagonals then? You guys that are drawing both of them, that's fine.
They bisect each other.
Okay, great. They bisect, so what's each piece, Spence? 5. And they're congruent, too. So everything's 5, right? I'm not going to go overboard. I'll just put a 5 here and here. All right, let's keep grinding. What else do we know? Darn right. Diagonals are perpendicular. The square has every property we know. Every property. And if we're trying to find the perimeter, what do you know about the sides of a square? I'll stop there. What do you know about the sides of a square? 5? they're all equal to each other. So if I know one, I know all four. You decide how you want to find that side. On you. It's on you. How do you want to find that side? A couple different ways you could go about it. I'll leave it up to you. How do you want to find that side? There's a couple different ways we've already talked about in this unit and today. You could find it. So I'll allow you to choose your own adventure. How many people use Pythag? How many people use 45, 45, 90 from today? And everybody, no matter what method you did you get 5 radical 2? Okay, doesn't matter how you get there. All right, 5 radical 2, which means all 4 sides are 5 radical 2. And let's go back to yesterday's discussion with adding radicals. Perimeter, 5 radical 2 plus 5 radical 2 plus 5 radical 2. And one more. Can I add all 4 of these? Can I add all 4 of these? Why can I add all 4? Because what's underneath is the same. Remember, you can multiply anything you want, but when you add, the numbers underneath have to be the same. And how many radical 2s do I have up here? 3. But whoa, I got 5 of them here. 20 radical 2. Okay. See where I got the 20 from? We got to add the numbers out in front. If I remove those, Spence, if I remove the 5s, then yes, you have 4 radical 2. But you got to add the numbers out in front and keep what's underneath the radical the same. You can do 20 that way too. You get 20 that way by multiplying them together. Correct. All right, you're right. Let's go. Let's go. And if you do end up finishing, you better get the Chromebook out and check your answers. Come on now, let's go.